Hey, welcome everyone. We're going to give everyone just a minute or two to join in, but thank you so much for joining us, and we'll get started in a minute. Okay, see we have a few more people joining in, but we will go ahead and get started. I want to thank everyone for joining us today. My name is Sarah Gagne. I'm from Dartmouth Engineering, and we are here today to talk about the online MEng in computer engineering at Dartmouth, delivered in partnership with Coursera. For this webinar today, please feel free to post any questions that you have in the Q&A. We will save a portion at the end of this session to address as many questions as we can live, and then we will follow up via email afterwards for any questions that we aren't able to address. We are recording this session, and we'll send out a recording along with the slides as well following this event. And without further ado, I would like to turn it over to Zofia Gatos to kick off this event.
Next slide, Ken. So welcome, everyone. I'm Zofia Gatos, the Director of Online Education at the Thayer School of Engineering at Dartmouth. I'm going to give us an overview of what we'll be talking about today. So I don't know if any of you attended our last webinar, but the content of this one will be slightly different. We'll cover some of the same information and also some new information today. We'll start by introducing our panelists, give you a very brief introduction to Dartmouth, talk about some of the online MEng program details, give you a little bit of a program overview, and then I will pass it off to our faculty director, who will introduce you to some of the faculty. And then we have two of our faculty here to give you some course previews. Then we'll pass it over to talk about financial aid options, our student services, the application process. And then again, as Sarah said, we'll leave some time for questions and answers at the end. Feel free to post your questions in the Q&A, and we'll get to as many as we are able to. We apologize in advance if we're not able to answer all of your questions, but we did design the content of this webinar based on some of the questions that we saw in our previous webinar. So that way we can really focus in on the content and really more about the student process that a lot of you had questions about in our previous webinar. So today our panelists will be Gene Santos, Professor Eugene Santos. He's our MEng faculty director. We have another one of our faculty joining us, Professor Jason Dahlstrom. I'm the Zofia Gatos, the director of online education. And then we have Ken Watson, who is our online education program manager. And we'll also hear from Ryan West, one of the enrollment counselors at Coursera. So Dartmouth was founded in 1769 and is a member of the Ivy League, and consistently ranks amongst the world's greatest academic institutions. We're located in Hanover, New Hampshire, which is a small town New England setting. We've got easy access to the northeastern metropolitan areas. We're only about 2 hours northwest of Boston. We're about 5-ish hours north of New York City, a little bit, about 3-ish hours southeast of Montreal. So we're really have easy access to the big cities, even though we're in a small town. It's a lively, inclusive community. We have a vibrant arts district, and we're surrounded by majestic mountains, rivers, lakes, and scenic byways. Here at Dartmouth, we're renowned for our deep commitment to an outstanding undergraduate liberal arts education and a graduate education with distinguished research and scholarship in the arts and sciences and at our leading graduate schools. The Thayer School of Engineering, which you may also hear referred to as Dartmouth Engineering, the Tuck School of Business, the Geisel School of Medicine, and the Gorini School of Graduate and Advanced Studies. And here at Dartmouth, our expansive network combines both the intellectual reach and the competitive strength of a leading research university with the accessibility and focus of a quintessential collegiate community, both in person and online. And that's something we really want to emphasize, right? Students coming into the online Master of Engineering and Computer Engineering are real Dartmouth students. You are our students. We want to make sure you really feel that. Next slide, please. So our Master of Engineering Computer Engineering program is the first fully online degree program at Dartmouth. We have some other hybrid low residency programs, but this is the first one that's going to be offered completely online. And it's offered through the Thayer School of Engineering at Dartmouth. And Thayer is one of the first professional schools of engineering in the country. At Thayer, we are really interested in preparing the next generation of leaders to solve problems through engineering research and innovation with a human-centered impact. So really thinking about how engineering relates to people. Our students enjoy direct access to faculty, and the faculty who are leading experts in their respective fields, and they learn in small, close-knit collaborative teams. And we're trying to keep that same feel as we transition into this online degree program. Next slide, please. Our online Master of Engineering in Computer Engineering is designed to be hands-on with collaborative projects that are rooted in active learning. We're welcoming our first cohort in March of 2024, and we'll follow the regular Dartmouth academic cycle. So Dartmouth is on the quarter system. We have 4 10-week terms per year, one starting in March, one in June, one in September, and one in January. And in this online Master of Engineering and Computer Engineering, we have a focus on intelligent systems. So that's the kind of focus area of this program. You'll not only master your technical skills that you'll need to do virtual and augmented reality, autonomous robots, self-driving cars, AI virtual assistants, wearable and implantable devices, and more, but you'll also gain power skills necessary for leadership and impact. So we really want to teach you both the technical skills and also some of these other power skills. And this program is set up with convenience and flexibility designed around your schedule. So these courses will all be offered online. You need to complete 9 courses in the program. You'll be taking 1 or 2 courses per term, and the terms are 10 weeks long, so they're a little shorter than you might be used to. And if you're doing it full-time, you can finish in as few as 15 months. If you're taking it part-time and you continue straight through without any terms off, it would take 27 months. So this flexibility will allow you to balance jobs, family, or any other responsibilities along with your schoolwork. On this slide, we've shown you a little bit of a snapshot of what the individual courses are, as well as a potential time frame. This will give you an initial idea of how the pacing and timing might look, depending on if you're taking the program part-time, where you're taking 1 class per term, or full-time, taking 2 classes per term. And remember, we're going to send the slide deck out afterwards, so you'll be able to look at this in more detail. We're going to give you a preview of how things might look for you. And these sample course plans show you continuing straight through without any terms off, but if your schedule requires it, you would also be able to take an off term in between without needing to apply for any special leave of absence. So you could take courses 2 terms, then take a term off, then take 2 more terms of courses, and then take another term off and adjust that as needed. And we will provide tools to help you make sure that you can fulfill all your requirements by helping you keep track of which courses you need to do in order to complete your degree. Now, next, I'm going to hand things over to our faculty director, Professor Gene Santos, and he'll talk you through why you should come here and talk a little bit about the course that he's going to be teaching.
Thank you, Sophia. So let me just introduce myself just again quickly. I'm Gene Santos. I'm the director of the MEng program here. Also a faculty here at Thayer, and one of the people who's going to teach one of the classes of your 9 classes. Let me just talk a little bit about Thayer a little bit more in depth. Dartmouth is a pioneer in computing innovations. If you haven't heard, Dartmouth first coined the term artificial intelligence in 1956 at a conference for the mathematicians on the premise that both learning and intelligence can be so precisely described that a machine can be made to simulate it. This meeting was the seminal event for artificial intelligence. I mean, we hear about it all the time. And so it started here. It was organized by John McCarthy, who, if some of you, if you don't know about him, please go look him up. He would be one of the fathers of artificial intelligence. And at that time, he was a mathematics professor here at the college. Another thing you might not know about is that less than a decade later, Dartmouth revolutionized computing with the introduction of the basic programming language. So if those of you who might have started off as your first programming language, like saying learning Visual Basic, this is what made computers accessible. Being able to communicate and have the computer do what you, well, try to do what you tell it to do in a way that was very intuitive. So that's Dartmouth. So next slide, please. So let me just highlight a couple of the faculty that will be teaching the courses in our computer engineering online. So there's myself. I specialize in intelligent systems and artificial intelligence. We have Professor Kofi Adame, who specializes in analog integrated circuits, low power sensor interfaces, and nonlinear signal processing. We have Professor Peter Chen, specializing in machine learning, differential geometry, and game theory. And then you'll also get to meet Professor Jason Dahlstrom today, who specializes in algorithms and embedded systems, as well as cybersecurity. Next slide, please. So what I'm going to do about, I'm very excited to talk a bit about the class that I'm offering for the 9 courses here. This is Applied Natural Language Processing. So what you should expect on Applied Natural Language Processing is the following breakdown of information. First of all, natural language processing is how we communicate. So, we want to start off with what's the basis of human language. So you'll learn formal elements such as natural language, grammars, the basics of computational linguistics. And then there you'll start getting exposed to what are some of the basic and standard techniques of just natural language processing. Some of you may already know these things like tokenization, which is what's the smallest piece of data that you can capture that actually has some information. And a token typically may be a word, or it could even be just a syllabus, or it could just be a part of speech, or it could just be a sound that is made that you can get some information out of. Other things like syntactic parsing. Well, if you think back to your days in grade schools where you're trying to figure out how to diagram a sentence, here's the noun, here's the verb, etc. That's very important. How do you make that computational? And then the last piece, which is truly for me what I think is the heart of natural language processing and why we're making strides now, semantic understanding. What does that mean? Meaning, when you get some information, when somebody says something to you, what does it really mean? How can we do that with a computer also? Now, of course, with all that being said, what are the challenges? What makes this problem really hard? It actually doesn't take much to think about. So let me just go back to semantic understanding again. Let me give you the sense called the rock ate. So you have a rock and it's eating. Rock is, an inanimate object. But if you look at it syntactically, just the way the sentence formed, it's valid. You have the rock ate. Very simple. Well, this tells us something. What if we were talking about the rock as some of you may know as Dwayne Johnson, right? So now that makes sense. That actually has meaning. These are some of the challenges we have to deal with. What's the ambiguity? That's a classic case of ambiguity. What's the context of, what you're listening to? You have other things like, what's the user intention? For us to communicate each other, there must be some intention going on. You're here for a purpose. I'm here to help you satisfy that purpose. And then there's a lot of really interesting things beyond that we humans take for granted many times. If you look at, there's things like garden pathing. It's like telling somebody a story, but deliberately leading them down the wrong path and then surprising them with a change at the end. Sarcasm, metaphors, poetry, bias. These are all the elements that makes this problem hard, but also makes it really cool of why we are interested in AI. Next slide, please. So from all that, we're going to look at the different tools for natural language processing. So not just from the basic structured tools that I was just talking about, the tokenization stuff, but what are the other things that you need? You might have things which are called ontological tools. This is how knowledge and meaning is organized. You have just even simple thesaurus. Why 2 words mean the same thing. So you have things like entity extraction, entity resolution. Some may have even heard of things called n-grams, which is trying to capture patterns, how words fit together. And then, of course, what's the state of the art? Large language models. I don't think I need to say too much to this group, but we will be looking at large language models, chatbots, prompt engineering, fine-tuning, all the things that are just really exciting, but also at the same time, one of the most important elements of this is, what are the limitations? This is what we hope to teach you from this class. And then lastly, fitting with the whole point of our entire computer engineering program, online program here for this Master of Engineering, is the applications, how you go about identifying the problem, how do you go about coming up with the solution, how do you develop an answer that's end-to-end, and then all the elements of validation and assessing, is it doing the right thing? And these want to be application driven. So you could have applications from, say, the financial sector. Hey, if I have news, sector, annual reports, all these assessments, what can I do with all that information? This is a natural language problem. What can this lead us to? So in a nutshell, this is what the applied natural language processing has been aiming to do. So let me stop there. I know I've already said too much. Let me now hand this over to Jason so he can talk about embedded systems.
All right, thank you. So before I tell you about the graduate level embedded systems course, let me first just define what embedded systems are. That might be a new term. So embedded systems can generally be defined as processor-based systems that perform dedicated functions. Because of this, embedded systems can be highly optimized for their functionality. Some common optimization constraints include size, weight, power, performance, and cost. And that's why the title of the slide says embedded systems doing a lot with a little, because designing against optimization constraints like these can make for some pretty exciting design challenges. So the last, I think, primary feature of an embedded system, and this is one that I personally really enjoy, is that embedded systems interact with the physical world through sensors and actuators. So on the left here, you see Dexter, and this is one of the robots I've used in the undergraduate course here, as a system built entirely of actuators. But Dexter's holding up one of the sensing systems you'll build in this course. And this is a high-performance analog sensing system built with a specific class of processor called a microcontroller. We'll talk a lot about microcontrollers in this course. And this project is a sample of what the course is all about. This is a course on microcontroller-based embedded system design with an emphasis on sensing and processing in intelligent systems. And next slide. Yeah, thank you. So here are some of the topics we're going to cover in this course. And you may have seen some of these before in an undergraduate course. If not, that's fine too. An undergraduate course in embedded systems is certainly not a prerequisite for this course. But in our graduate level course, we're going to cover these topics in more in depth, or probably more correctly from the ground up. Because our course begins where modern computing begins, with the transistor. And the course works its way up through the architecture of embedded systems, and then across the details of how our design tools work in concert with the architecture to help us realize our design objectives. So we'll then take multiple passes at sort of the core functionality of these microcontrollers, and that's data input, processing, and output. And we're going to explore this first with basic software and hardware techniques, but we'll revisit these capabilities a few more times as the course progresses with increasingly advanced hardware and software techniques. So I mentioned that an undergraduate embedded systems course is not a prerequisite, but you will absolutely want a solid foundation in C programming for this course, and at least some exposure to basic analog and digital electronics before taking the course. This is very much a hands-on course. We have multiple programming and hardware design projects that you will do on your desk. We get into these projects in the first week, and the course builds on itself week by week. So it's really important to start the course confident in your C programming skills and comfortable with these basic electronics concepts. So what should you expect from this course, right? That's the question I'm trying to answer for you here. And that is that at the end of this course, you will be able to design, develop, prototype, test, and build embedded systems that can sense in and interact with the physical world. So when you get to the end of the course, my question for you will be, what will you create? Thank you.
Thanks, Dr. Dahlstrom. I'll take it from there. I would really appreciate yours and Dr. Santos's description of the courses. I think learning more about the content certainly gets me excited about it, and I'm not eligible to take the program. So hopefully our prospective applicants out there are as excited as I am. So I'd like to shift the focus a little bit here towards some of the student support and resources that are going to be available to you while you're working your way through this program. Certainly the curriculum and the content are a huge piece of what you'll be taking away from this degree program, but so is a number of student support services and resources that are going to be available to you. And so we'd like to point some of those out to you now. As Zofia mentioned at the top of the presentation, it's really important to us that you feel like you are just as much a member of the Dartmouth community as students who are on campus. And so to that end, we're doing quite a bit of work now to ensure that when students join the program, they have full access and they know what's available to them as students. So first and foremost, you will have access to our financial aid office at Thayer. It's important to point out this degree program is eligible for all of the standard federal financial aid that's available to U.S. citizens and permanent residents. Oftentimes this is in the shape of loans, but those loans that are available to other traditional on-campus programs are available for this program as well. For our international students, our Coursera partners have put together a pretty extensive list of resources for you to find funding opportunities, and we would encourage you to check those out. You can do that either by connecting with one of our enrollment advisors at Coursera, or just going to the Coursera website and searching for international student funding, and you'll find a link to a number of websites available to you to help identify funding opportunities. In addition to that, there are a number of scholarships and grants that we will support all students, both within the United States and internationally, to work with you to identify these opportunities, submit whatever applications you may need, and help you identify those funding resources. And for those of you who are employed, we highly suggest that you chat with your employer, let them know that you're interested in doing this program. In many cases, if this degree program aligns with your work, the employer benefits from your education just as much as you do. So in many instances, they may be willing to share the costs. So it's certainly worth asking whether your employer has a tuition assistance or tuition reimbursement program. And then the last piece on financial aid is, in most cases, you need to be enrolled at least part-time. As Sophia mentioned on the slide with the sample course plans, part-time for this program is just one course per term. So as long as you're enrolled in at least one course, you should be eligible for most forms of financial aid. So that's one piece that makes up the student services and resources available to you. There are a number that are equally as important, including our colleagues over in Dartmouth and Thayer Computing Services and the Dartmouth Library Services team. So these folks offer a number of virtual support and will work with you on both the research side and working with you on your technical hardware needs. So we encourage you to reach out to them as much as you need to. Students also have access to the Student Wellness Center, particularly an organization we work with called You Will, which is a telehealth organization that does student mental health and wellness support. So if you're enrolled in this program, you would have access to You Will, just the same as all Dartmouth students, and your Dartmouth student ID card. Even if you're not in the area, we will send you instructions on how to upload your picture and request a DART card, and we can work with you on retrieving that card for you and getting it mailed out to you wherever you may happen to be. So you will officially be a card-carrying member of the Dartmouth community. Our networking opportunities and alumni associations are broad and expansive and offer a number of resources. I'm gonna go into a little bit more detail there on the next slide. But I would also like to invite you to attend our investiture and commencement ceremonies. I know it's early. I know that you are, haven't even been admitted to the program yet, but we'd like to kind of plant the seed here and let you visualize what it will be like when you have completed this degree and you put on your cap and gown and you come to campus and participate in the commencement ceremonies with your fellow graduates to celebrate your accomplishments. And we'll be here to celebrate with you. So the Dartmouth Alumni Association I mentioned is broad. They do a number of efforts to help students engage, connect, learn, and serve. And they're all over the world. And so these efforts include some of the standard things that you may have encountered with other alumni associations, including things like homecoming and class reunions, supporting regional clubs and organizations. But they also do some other unique programming that I think is pretty cool, including Dartmouth on Location, which are events that are hosted around the world where members of the Dartmouth community, current members of the Dartmouth community, will go out and discuss what's going on campus. It could be research, it could be new initiatives, but help folks in that community feel like they're plugged in to what's going on at Dartmouth. It's a good way to connect with other alumni in the area without necessarily going through one of the regional clubs or organizations. And they do events that are family friendly as well. There's Dartmouth on Location for kids, where they've done events at zoos and other places that are family friendly and can involve every member of your family. There's also continuing education opportunities through Dartmouth X. And so this includes things like workshops and training sessions that are available to alumni. So, you know, even if your time in the classroom has come to an end, you know, you have the opportunity for lifelong learning through continuing education opportunities with the Alumni Association. Perhaps one of the more important teams on campus is our Thayer Career Services team. We're all important, but they are especially important. Whether you are looking for your first job or you are in your career and looking for ways to advance to the next step, or perhaps you're looking to change careers, our Career Services team has a number of resources available to you that can be done virtually to help you kind of figure out what the next step is going to be in your job trajectory. This includes everything from career advising and coaching to reviewing resumes, doing interview practice and preparation, and hosting a number of virtual career fairs. If you happen to be in the area and would like to come to campus, we would certainly encourage you to connect with our Career Services team at that time, and they can do many of this in person as well. And the logos that you see there at the bottom are just a few examples of where some of our graduates have gone on to fruitful careers. So we encourage you, it's never too early to get in touch with the Career Services team and start finding out how they can help you reach the next step of your goals. So with that in mind, I'm going to hand it over to my colleague Ryan, who's going to walk us through a little bit more in depth of the application process.
Good afternoon, everybody. My name's Ryan. I'm an enrollment counselor with Coursera, supporting this program. And for anyone who I have had the chance to speak with, it's good to see you if you're on the webinar, and maybe I'll get a chance to speak with some of you others as well. But as far as applications, currently for the March 25th cohort, applications are open. The priority deadline will be January 15th. Of course, the benefit of a priority deadline is not only getting a decision sooner, but also in this case, you can have your application fee waived. And then the final deadline for the March cohort will be February 15th to have your application materials in. It is important to understand the applications are looked at holistically. The benefit of that is if you feel maybe there's one or two areas where you have a little bit of a weakness or didn't do as well academically maybe as you would have hoped, the application allows you to put together a case for yourself. You can really build into the application your strengths. You can showcase things you've been a part of, skills you have. And what it does is allows the admission committee, when they're reviewing applications, to get a great sense of you as a whole and you're fit for the program. So keep that in mind. You'll have that opportunity, very unique opportunity to really share a lot about you, your background academically, work-wise, if you have work experience, and skill sets. And then coming on to the fall applications. So the next cycle or next cohort will begin September 16th. The deadline for that, priority deadline, will be June 15th. And then the final deadline will be July 15th for the fall cohort. One thing to realize, if you would like an earlier decision, you do have the ability to submit your fall applications during the review for spring applications. So if you get in your fall applications by the January priority deadline or the final deadline in February, you can receive a decision early for the fall timeframe. But same thing from there. I'll be here to support anybody with questions in the process. There are no silly questions, I promise. So I'll be here to support you through any of the steps that you have and questions that you have.
All right. Thank you so much, everyone. We've had some great conversations. We've got some great questions that have been posted in the Q&A. So right now, we will open that up and we will start addressing the questions that we've been receiving. So the first one that we'll start with, we have an applicant who is applying for spring, and they are wondering for their recommenders, the recommenders are wondering what kinds of topics should they write about when recommending this applicant. And Ryan, I'm wondering if this is a question that you could address.
Sure. When it comes to recommendations, as many of you may have experienced, sometimes job recommendations can be a little bit generic or formulaic. If you've seen standard recommendations, oftentimes could be as simple as this person's a fantastic employee, they show up to work on time, hard worker, team player, but all very generic details that are provided. What can be really helpful in recommendations is speaking to the specifics, whether it's work that you've been doing in the classroom, if it's an academic recommendation, or in the workplace, if it's a professional recommendation, specifics to what you've been involved in, as well as characteristics or traits that you've expressed in class or in the workplace that line up relevantly with the program, motivation. But going back to that, if you can share with your recommenders to give a good thought out recommendation where it's not generic, but they do speak to who you are as a person, the things you've been involved in, the integrity of your work, classwork, or in the workplace, those things will be very helpful. The point of a recommendation is not to reiterate necessarily other things in the application, but it's to give a different perspective from somebody on the outside and to add additional details. So the more they can provide specifics to add to the application, the stronger potentially those recommendations can be in sharing more about you and why you'd be a good fit for the program.
Great, thank you, Ryan. See, another question that we received, would there be research opportunities for online students? And Jean, I'll direct that to you.
Sure. Unfortunately, not as much. You know, the research opportunities are usually working with a particular faculty member, and a lot of that is available in the on-campus residence program. So I would strongly advise, if you're interested in research, to look there and also look at the research programs that Thayer Engineering offers.
Thank you, Jean. Let's see, another question that we've received. This person says, I've noticed multiple courses on hardware engineering. For what student profile is the program targeted for? Is it more aligned and targeted for students with electrical engineering background than computer science? Is that something else, Jean, that you would like to, you could address?
Sure. Actually, it's a mix of the two. If you, for example, look at the course in machine learning and look at the course in my course, the advanced natural language processing, that would then make you think that's more targeted to computer science. We're looking at a mix of both, you know, because you'll get the experience, like from Jason's embedded systems class, of looking at the hardware elements. You'll get the software experience from my class. And then for the capstone project, it also brings all these things together as well.
Great, thank you, Jean. Another question that we received is about the GRE. This person is wondering, how important is the GRE test for showing quantitative ability in the application, especially for applicants coming from the European university system? And Ken, I'll direct this to you if you want to just talk a little bit about our holistic review of applications and GRE scores.
Absolutely. So as Ryan pointed out on his slides, we really do approach the application review for this program holistically. And we keep saying that word, but really what it means is that we're looking at every single aspect of what makes you, what you've put into the application. And so that includes your performance in undergraduate degree programs or in previous graduate degree programs, your work experience if you've got it. Maybe it wasn't necessarily with an employer, but it could have been from an internship or research that you did in a lab somewhere, or working with a faculty member. Your statement of purpose is an important aspect of your application, and so as are your letters of recommendation. Again, as Ryan was talking about, so all of these components are looked at in a way that gives us a well-rounded picture of who you are. And the GREs are not required, but they can be a supplemental component to that gives us a sense of what your accomplishments look like, and whether or not this program is the right fit for you. And so I don't know that I would classify any single component of this application as a quote unquote a make or break piece. I think that if you have strong GRE scores, then that can certainly help, especially if it helps supplement another part of your application. Perhaps you weren't quite as successful in undergraduate courses because you were still trying to figure out what it was you wanted to do. And you've found that now, and then you're able to use some of these test scores to help supplement that previous experience. So it is a piece that is considered. It's not necessarily any more important than any other component of the application. We really do encourage you to share with us as much as you can. That helps us gain a better understanding, the best understanding we can from looking at printed material of who you are and whether this program is going to be the right fit.
Great. Thanks, Ken. So we've been getting some good questions about people who are trying to kind of understand what types of backgrounds and undergraduate degrees would be suitable for this program. And so we have people that are wondering, on the one hand, if they have an ABS computer science degree, would that be considered efficient and then sufficient? And then we have other people who are wondering, is there a path for those whose bachelor's degree is unrelated to computing? So it's kind of two ends of the spectrum. And maybe I could turn to Sophia and or Ken. If you want to just talk about those two ends a little bit.
Yeah, so there's, you don't necessarily have to have a degree in computer engineering, but you need to have the equivalent experience. So whether that's, you have a degree in a humanities background, but then you've been taking online courses online or in person somewhere in computer engineering or related fields, like taking programming courses, taking math courses that you've done at community college, or you've done them online, or maybe you're working in this sort of field, that could give you an equivalent preparation. So we're not looking specifically for a particular degree. We're looking for a demonstration in your application that you have the academic background and preparation to be successful in the degree program. Because what we don't want is for you to get here and find that you're miserable because the preparation that you've had doesn't make you ready for this program. So, you might have noticed that for the embedded systems course, you will need some C programming skills. If you don't already have C programming skills, one way you can get that is with the C programming with Linux specialization that we offer on Coursera. So this is open content that you can take right now to brush up on those skills or gain them if you have programming familiarity in other languages, but not C, or if you haven't done a lot of programming, this might be one way to gain some of those skills. Anyone else have other comments to add on background and preparation?
I think you've hit the nail on the head, Sophia, and I will say that we want to make sure that we're presenting a opportunity for folks to come to this from different backgrounds, but ultimately, it is a graduate level STEM degree program, and so it's important to ensure that I saw a description that these courses are entry level courses of advanced topics. And I thought that was a decent way, with the exception of a few of them, which are advanced level courses of advanced topics. And so I thought that's a good way to think about it. That it's important to understand what you're getting into when you're coming to this program, and it's about as much for us making sure that this program is the right one for you, and that you're not going to be, as Sophia said, you're not going to be frustrated and miserable, but that you feel well prepared. And this will help take your education to the next step.
Great. Thank you, Ken and Sophia. So I've been addressing a lot of the questions too via chat as well in the Q&A. Let's see. Sophia, I wonder if you could talk a little bit more. And at one point, you talked about how we will send kits to students. And if that's something, could you just explain on that, touch on that a little bit more as well?
Yeah, I'm actually going to bump this over to Jason because he's been thinking really hard about how to balance all of the different factors that we want to think about when we're doing something like this.
Yeah, thank you, Sophia. Oops, yeah, I'm off mute. I had a feeling that one was coming my way. So I've been thinking hard on it, but we've all been working very hard on it across multiple departments here and with Coursera to make sure that every opportunity to be successful exists for you to do these hardware experiments on your desktop. And in the embedded systems course, there inevitably is the one build that just won't work. So the course is also a little bit resilient to the situations where your kit doesn't ultimately work in the end. So you can still be successful in the very challenging sort of problem of doing what's normally done in a laboratory classroom here on campus on your desktop with these hardware kits. But as Sophia said, we'll be shipping these kits out to you. And then there's in the embedded systems course, one piece of software, it's a commercial piece of software that runs on Windows and on Linux and on OS X that's used to tie back to all of the tools that are used to work with that hardware back within the Dartmouth and Coursera infrastructure.
Great, thank you. Let's see. I think we've been covering up most of these questions. Let's see. What else? I'll put this to the panelists. What else? And I know we have a few minutes remaining left, but are there any other topics that you think would be helpful to dive into a little bit further based on the questions that we've been getting today? Actually, I see another question that came in for students that are kind of wondering about switching between, from the online to the on-campus. And this question is about would international students who later transfer on campus qualify for OPT? And Candy, I don't know if that's something you wanted just to speak to just briefly about students and how that kind of works, at least with the residential program.
Yeah, so it's my understanding that you'd need to be in residence 3 terms, consecutive terms, in order to qualify for OPT or any of those programs. And with the way this is set up, that's certainly not possible in the online space if students are on campus. I did see a question about switching from one path to another. That can be done once. It would be really difficult to have students going back and forth between residential and online. So the thought process is that switch could be made once. Whether or not that would allow a student to be here for 3 consecutive terms, that would have to do in how coursework was laid out.
Great, thank you, Candy.
Sure.
Another question that we received is just somebody who's wanting to know how they can demonstrate their strengths, maybe if their GPA is a little bit on the lower side. And Brian, can I turn this over to you to talk about the elements of the application that are in there to help applicants and demonstrate their skills across the different core foundational areas, as well as group work and project related experience?
Sure, absolutely. So as far as demonstrating strengths, you'll have a few different areas, of course, in the application. From a work or academic standpoint, of course, a resume or curriculum vitae, you can demonstrate very specific details, responsibilities that you've had, things you've been involved in. That's a little bit more of a formal document where you can highlight those skills and put them prominently on the resume or curriculum vitae. And then, of course, other areas, the written statements. You have a statement of purpose, more or less, that allows you to share about your intentions, a little bit more about your background and things. But there's also supplemental documents you can add to highlight additional strengths or provide a little bit more background on yourself. If there was an area of weakness, you have the opportunity to share a little bit about that. Of course, you want to have an amount of brevity, right, where you're not writing for one particular area too long, but you want to give enough detail to shed some background on that. So the written statements are a fantastic area to provide more detail from that standpoint, really to highlight those strengths. And as we talked about before, you're able to do learning outside of just formal college coursework, right? So if you have other avenues where you've learned through open content, or you've learned skills through your work, don't forget to highlight those, explain a little bit of detail about what's involved. Oftentimes with people I'm speaking about, a lot of times, even though their main position may not be directly related to some of the coursework they're doing, but through work they've had responsibilities that tie into it, right? Or they're dealing with people in those areas. Those are all things you can share in your application to provide more detail for the committee to get a good, clear understanding of where your skill sets are, what your experience is, and things from there. So definitely take time to highlight those, and you can provide a little bit of background if there's areas of weakness. You can provide some background on that as well.
Great, thank you, Ryan. Okay, let's see. Zofia, are you seeing anything else that you think would be helpful to address at this point? Just want to be mindful of time, but I think we've been actually addressing most of these questions, and certainly we're going to be following up with the recording and the slide deck. But is there anything else that you would like to end the session on, Zofia?
Yeah, I just encourage you, if you have more specific questions, to reach out to the email addresses here, right? For general information about the program, you can reach out to dartmouth-meng@coursera.org. For questions about your application or financial aid, you can reach out to online.engineering@dartmouth.edu. And we encourage you to reach out if your question didn't get answered or you have additional questions. And we're really excited and hoping that we'll be able to welcome some of you or many of you to our first cohort this March. Thank you for taking the time to join us today.
Great. Yes, thank you all. We appreciate everyone's time today. And so with that, I think we will go ahead and end the session, and we look forward to continuing our conversations. Thank you very much.